All right, here we go. Let's take a look at section 9.2. You can see right here there are a few vocabulary words that you can go ahead and copy down into your notes. We start off with initial side, which is your starting side or ray. We have a terminal side, which is the ending side, or which happens to be the ending ray. We move down right here. We'll talk about standard position as we take a look at our notes a little bit further down. Next up is coterminal. That is when angles are in the same location. The big thing right here in this section is talking about radians or a radian. A radian is a unit of an angle that is equal to an angle at the center of a circle whose arc length is equal in length to the radius. Now, if you want a little more in-depth definition for radian, if you take a look at your textbook, you can see it there. I think for our purposes, the main thing you need to know about radians is that it is an equal measurement to angles. It's like you can convert something from like an angle to a radian and a radian to an angle. Similar to that of, let's say, temperature. When we talk about like Fahrenheit and Celsius, you know that 90 degrees Fahrenheit is, you could change that and convert that into Celsius and vice versa. So it's kind of like two different units of measure, but they are equal to one another. All right. We take a look next up at sector, which is a region of a circle bound by two radii and an arc. And then we have a central angle, which is definitely something you looked at in geometry, which is an angle formed by two radii. Let's go ahead and take a look right here at our first core concept. It says angles in standard position. I have highlighted right there an angle in standard position is in standard position when its vertex is at the origin and its initial side lies on the positive x-axis. So standard position and where they're talking about to be the starting point is going to be, there's your vertex and our initial side right there. That would be my standard position. And then when we measure or talk about angles, we go from our initial side and then we will figure out our angle going counterclockwise right there, as you can see in the diagram. And so where it ends right here, I'll highlight that in blue. That would be your terminal side. And so this right here would be my angle, whatever it would end up being. Looks like right here, we could say, what, 120? All right. So now that's where your initial side and terminal side actually is. All right, moving along. So in order to convert between degrees and radians, you just have to multiply right here. And so to go from degrees to radians, you're going to take whatever angle you have and multiply it by pi over 180. And then if you want to go from radians and you want to convert that to degrees, then you're going to multiply whatever you have in radians, then multiply it by 180 divided by pi radians. All right, so it's a very simple conversion to go from degrees to radians and radians to degrees. Definitely something right here you are going to want to memorize. All right. So make sure you memorize how to convert. Now, as you begin to do this quite a bit, converting from degrees to radians, radians to degrees, what you see right here is a unit circle. And these are a lot of the main angle measurements that we're going to be using. We start right here at 0, and then we go counterclockwise. We have 30, 45, 60, 90. So remember, these angles right here we talked about a lot with 30, 60, 90, and 45, 45, 90 right triangles, or special right triangles. Some of the main things that you need to figure out is, I mean, we should probably already know, if we start right here at 0, and then when we go full circle, then that's 360 degrees. Well, in radians, we could also start right here, initial side being 0. When we go 360 degrees, that's the same thing as 2 pi. So what you'll hear oftentimes is a range from 0 to 360. That would be in degrees. In radians, it would be from 0 to 2 pi. Now, right here, you can see a bunch of different measurements, conversions from degrees to radians. You could technically take every single degree measurement and convert it to radians. However, that takes a long time. That's a little extra step that you don't need to, that you're going to have to take in order to answer some of our problems later on. So it is helpful to make sure you memorize these. Okay, you'll be using it quite a bit, not just right here in Algebra 2, but in math analysis and in calculus. A lot of these measurements are going to be used quite often. So the sooner you memorize them, the better. You can see some of the patterns and numbers that happen to appear. Like, look at the denominators. We got 3, 4, 6. And then if we look right here on the second quadrant, you can look at the denominator 3, 4, 6. 3, 4, 6, 3, 4, 6. All right, so that could be some part that helps you memorize a lot of these angle measurements when it comes to our circle and from degrees to radians. One other terms that was that we had earlier on in the vocabulary section was that of a coterminal angle. Okay, if we go back up right here, let me go ahead and say angles in the same location. Now, there's nothing in this section that talks about coterminal, but let me go ahead and take a look at, once again, this is our circle, and let me try to give you an example of what are exactly our coterminal angles. So a coterminal angle, so let's say we start right here. We know that this is 0 degrees. Okay. If I go one time around our circle, that one time around ends up being 360 degrees. So when we talk about coterminal angles, those are angles that have the same side, right? They have, when we talk about the word co, like coexist, those happen to be, so these happen to have the same ray or the same terminal side. So that's why they're called coterminal angles. So if you take an angle and you add 360 to it, then that will be a coterminal angle. Or you could even subtract 360 to this. So if I, right here, if I went around one time, that's 360. If I go around a second time, right here, that happens to be 720 degrees. So I could say that all of these three angles are coterminal angles. I can go subtract 360. And so a coterminal angle to 0 degrees could also be negative 360 and negative 720 and so on. Let's say my angle, I start off with 5 degrees. A coterminal angle to 5 degrees would be 360 plus 5. So 365 degrees would also be considered coterminal to 5. All right, so there's your little briefing on what is a coterminal angle. All right, moving along. We'll talk about arc length and area of a sector. I'll have a problem for you that we'll look at later. But right here, this is very important whenever you're solving this type of a problem, is that the arc length S and area, capital A, of a sector with radius r and central angle theta, and this has to be measured in radians, are as follows. So you could use, and you need to memorize these two equations, one for arc length, one for area. But in order for you to use it correctly, you have to make sure that theta is measured in radians. So you're going to have to convert it from degrees to radians in these problems. All right, and so make sure you do not forget that. All right. So let's take a look right here. We'll look at number 1. It says draw an angle with the given measure in standard position. Okay, so remember, we always start off right here. This will be our initial side, and then we need to draw from here. We go counterclockwise at 260 degrees. We should know that, look, if we take 360, we divide it into 4 parts. This is 90. This right here is 180. We add another 90 to it. We end up with 270 down here, and then back to 0 and 360. So if I'm here to draw an angle with measurement of 260 degrees, then we would start here, and I'll just go ahead and draw this little arc, and then let's, from the vertex to here, we'll just say that that is 260 degrees. It'll probably be a lot closer than it is right here to the 270. All right, but that right there would be how we figure out where 260 degrees is. All right, taking a look at number 2, if I want to go negative 750 degrees, now when we go positive, we go counterclockwise. If it's negative, we're actually going to go clockwise right here. And so let's think about this. We go around 1 time. So I'll start right here from our initial side. We go around once, that's 360. Right, that's 360. Now, let's go around a second time, because when I multiply 360 by 2, that gets me 720, right? Coterminal angle. And then from there, we need to add another 30 degrees to get up with negative 750. So 30 degrees, we can go ahead and say is approximately right here. Okay, and so if I were to finish this out, this right here would be negative 750 degrees. Okay, and there you go. All right, so it says find one positive angle and one negative angle that are coterminal to the given angle. And the key here to this is adding 360, subtracting 360. Okay, very simple. So if I take right here 55 and they want what positive one, we could add 360 degrees to this. And then we come up with our angle right there. And that would end up being 415 degrees. Next up, we could take right here 55 and subtract 360 degrees. Simplify that, and then we end up with negative 305 degrees. So these right here are your two coterminal angles. One positive, one negative. Okay. Sometimes you might have to subtract 360 more than once, or add 360 more than once to your angle in order to make it positive or negative. All right. Let's go down to number 7. So we have something that's in degrees and we want to convert that to radians. Okay, so remember we have two equations. It's either going to be 180 over pi, or we multiply by pi over 180. If I have something in degrees right here, what I'm going to do is take the 54 degrees and we're going to multiply this. Now think about it this way. If I'm going to maybe do some cross canceling, and some of you may have done this when you did converting in maybe your chemistry class. I want to eliminate the degrees. So you got to think, well, is it going to be 180 over pi or pi over 180? Okay, so I want to multiply this by pi over 180. Because think about it this way. What ends up happening is that degrees will cancel. And what I'm left with is this pi. Usually in radians, we're going to have that pi right there in your answer. So let's go ahead. We'll multiply this out. You could do some cross canceling. Make sure you guys leave things and reduce. And we're left with 3 pi over 10. Do not give me a decimal answer. I want exact answers right here. You'll leave this in terms of pi. Okay? So degrees cancel. I'm left with pi left in my answer. And then I know that we are in radians. With number 8, we can do this real quick. So we have negative 310 degrees. We'll multiply this. We want to take from degrees to radians. So once again, we'll multiply this by pi over 180. Reduce it down, simplify it, and you're left with right here, negative 31 pi over 18. Okay. On number 9 right here, we're going from radians to degrees. I know I'm in radians. We have this pi right here in our problem. So let's take 16 pi over 15. And then think about this. How am I going to be able to cancel out that pi? Well, if I multiply it by 180 over pi, then the pi's will cancel out, and then I can go ahead and cross multiply and then simplify things. So see right here in this instance, the pi's will be eliminated, and then we'll be left with our answer in degrees. So make sure you guys simplify it. You could use your calculator, and we are left with 192 degrees right here. So lastly, we got negative 2 pi over 5. We'll multiply that by 180 over pi. So once again, it works out nicely. The pi's cancel out. You can go ahead and start simplifying, and then you'll end up with negative 72 degrees. And don't forget the negative, because that was there initially in our problem. the last problem right here, there's a similar question in the book that talk about arc length and finding the area of a sector. I'll go ahead and put this up right here. Maybe you could draw this out in your notes in this part that does say arc length and area of a sector. What we have right here is, let's say, like a baseball field. Okay, we have two sides that happen to be the foul poles, and then we have which happen to be like considered like the radius or the radii. So this is 400. That makes this side right here 400. We also have this. This is supposed to be an arc. I know it's not perfect, but just think of this as a circle, and this is the arc that's part of the circle, or the cone, or the outfield of our baseball field right here. So what they're going to ask you is two things: find the arc length and find the area of the field. Okay. So remember, in order to find arc length, we have our equation. And we have it as S is equal to, we have theta, or radius, times theta. Okay, that's our equation for arc length. Now, remember, this is supposed to be a baseball field. This right here, we have 90 degrees. Okay, it's supposed to be a right angle. So right here, they're saying, first off, what is the radius? We should know that that's what 400 represents. So R is equal to 400. And the angle measurement right here happens to be theta. Okay, don't forget. This is theta. But we need to make sure that we convert our degrees to radians. Okay, so let's go from degrees to radians. And so we've got ourselves 90 degrees, and we multiply that by, hopefully you put down, pi over 180. All right, so we multiply this, we'll go ahead and simplify it, and we're left with pi over 2. Okay. So in order for us to find the arc length now, what we're going to do is take our radius, which is 400, and then we'll multiply that by our angle, which is pi over 2. You can go ahead and simplify that. And if they ask for an exact answer, which you may see, this right here just turns into 200 pi. Okay, so big ideas may ask for exact answers, or they could ask for a decimal answer as well. This right here turns into 628.32. And since we're dealing with, we'll go ahead and say feet. And we'll say this is measurement in feet. All right, so that right there, we just found arc length. Okay. We'll go ahead and move on to the next part, and we want to find the area of the field. Okay. So if you think about the area of the field, this would be the area of your sector. So the area of the sector right here, we have our equation, and it's going to be 1/2. We have ourselves r squared times theta. Okay, so there's your area equation. We have just plug some things in right here. Most of this we already know. We have 1/2 times our radius, which is 400. We square that, and then we need to multiply that by, I'll put that in red, we have pi over 2. Okay. If you go ahead and simplify this out, make sure you do your order of operations. You have 400 squared. You need to make sure you do that first, and then multiply that by 1/2, then multiply it by pi over 2. This right here ends up simplifying when we want, if you were to give an exact answer, it would end up being 40,000 pi. If we were to get our approximate answer, it ends up being 125,663.71. And we're talking about area, so it's going to be feet squared. All right, that concludes our lesson for 9.2.